Welcome to Physics Dream Team Classroom, College Matrikulasi Pahang Kementerian Pendidikan Malaysia. Chapter 8, Rotations of Rigid Body. An overview for rotations of a rigid body. There are 4 subtopics that we're going to cover under this chapter, where the first one is rotational kinematics. In rotational kinematic, we're going to learn rotational linear relationship and rotational motion with uniform angular acceleration. Second one is the equilibriums of a uniform rigid body. In equilibriums of uniform rigid body, we're going to learn on torque, where torque is equal to cross product between R and F. For the third subtopic is rotational dynamic, where under this subtopic, we're going to learn on moment of inertia and summation torque equal to I alpha. The last one is conservations of angular momentum, where under this conservations of angular momentum, we're going to learn on angular momentum and also principles of conservations of angular momentum. The next parameter in rotational kinematics of rigid body is average angular acceleration or alpha average. Average angular acceleration can be defined as the rate of change of angular velocity, or in mathematical equation, it is delta omega per delta t. The last one is instantaneous angular acceleration, or alpha. It can be defined as the instantaneous rate of change of angular velocity, or the first differentiations of angular velocity. Let us proceed with relate parameters in rotational motion with their corresponding quantities in linear motion. Let us start with displacement. The symbol for displacement in linear motion is S, where the symbol in rotational motion is theta. The relationship between linear motion and angular motion is S equal R theta. The second one is initial velocity. The symbol for initial velocity in linear motion is U, and in rotational motion is omega naught. And it can be related by using equation U equal to R omega naught. For the final velocity, the symbol in linear motion is V, and its symbols in rotational motion is omega. And the relationship between linear motion and angular motion for final velocity is V equal R omega. The last one is acceleration. The symbols of acceleration in linear motion is A, and in rotational motion is alpha. The relationship between linear motion and angular motion for acceleration is A equal R alpha. The second subtopic in rotationals of rigid body is equilibriums of a uniform rigid body. The first one that we're going to learn is torque, or moment of forces. Torque can be defined as the product of the force and its perpendicular distance from the line of actions of the force to the point or rotation axis. The equation for torque is torque equal to cross product between R and F. Sometimes The torque, also known as a tuning or twisting effect of the forces on a body, where the torque will depend on rotation axis and also the magnitude of applied force. Rotational dynamic. Rotational dynamic is the third subtopic in rotations of rigid body. Rotational dynamic can be defined as the sum of the product of the mass of each particles and the square of its respective distance from rotation axis. The factor that affect the moment of inertia of a rigid body are: the first one is the mass of the body, the second one is the shape of the body, and the last one is the positions of the rotation axis. What is torque in rotational dynamic? Look at figure 2. Consider a force F acts on a rigid body freely pivoted on an axis through a point O as shown in figure, where the sum of torque equal to I alpha. The last subtopic that we're going to learn in rotations of rigid body is conservations of angular momentum. What is angular momentum? Angular momentum can be defined as the product of angular velocity of a body and its moment of inertia about rotation axis, or simply can be written in mathematical form L equal to I omega. Angular momentum of a rigid body is conserved. According to principle of conservation of angular momentum, it states that a total angular momentum of a closed system about a rotation axis is constant, or I omega is constant if the sum of torque equal to 0. Therefore, the total initial momentum equal to total final momentum. Let us try this exercise to enhance your understanding. Which of the following does not affect the moment of inertia of a rigid body? A. The size. B. The mass. C. Rotational axis. And D. Angular momentum. What do you think? According to the formula, I equal to mr squared, so the moment of inertia will depend only on the size, the mass, and rotation axis. Hence, the answer will be D. Before we end the lesson, let us think about this quote. You learn more from failure than from success. Don't let it stop you. Failure builds character. Happy learning. Thank you and see you again.